Hi everybody, in this video we'll talk about densified curves, what they are, how to detect them, and how to fix them. So let's look at the data here. It's hard to see if I have a densified curve, and it will be easy to explain just by going to the quality tab, go to the parcel layer, and display the line vertices. So I'm going to press that, and I'm going to apply the parcel type I want, and press OK. And now we can see those green vertices, and there's a concentration over here, so we can zoom to this area, and this is a densified curve. You see how many, there's so many vertices here, it looks like a solid line, but if we start zooming in, we'll start seeing that actually it's made from multiple vertices. So there's two types of curves. There's a true curve, where it's defined parametrically with parameters, or it could be defined as here with so many vertices, and that's of course something we don't want to have, and the reason is from geometry storage perspective it takes more storage, and then if you have any alignment to this line, you have so many vertices that it might cause you to do more work. So we would love to get rid of those vertices. And how would we get rid of those? They might also be applied on the polygon. They could also extend through multiple parcel types, so we might have the lots, the subdivision, the tax parcels also have the same problem, and we want to fix them all at the same time. So to fix this area, I'm just going to select this area here and make sure everything is selectable, and then go to the simplify by straight line and circular arc tool, and that's a geoprocessing tool, and I'm going to choose the lines I want to fix. So I'm going to choose the lines of the tax parcels, but I'm also going to choose the polygons. So I want to fix them always in the same time, so they get the same approximation and the same fix applied in the same time. So that's really important. Let's do the same for the subdivision lines, and also do it for the subdivision polygons. And I'm also going to apply it to the easements, the encumbrances, and the lots. So for this demo, I'll just choose the lots lines. Okay, so lots and unit line and the lots themselves, and I know there's no easement here, so I'll skip the encumbrances. Now let's put some parameters. How much do I allow the data to move in order to fit a true curve into those vertices? So I'm gonna go with a half a feet here. It doesn't matter too much if it's a survey feet or international feet. We're going to choose fit to vertices. We can choose minimal and maximal radius. So I'm going to put something minimal and something maximal. I never want to get those shallow curves that look like a straight line. So it's good to have a maximum value when we're fitting. And if we have points, I can also use my points as anchor points, so the end of the curves doesn't move. And that's great. I'm going to switch the undo here so I can review the result and just press OK. So now it's processing all those features in the same time, fitting the same curves. And if I've done everything correctly, when we remove the selection, no more densified curves. So you can see here this was out of the selection, we still have one, and here it has been fixed. So this is how easy it is to detect them and how easy to fix. One thing to mention is if you see a lot of points on those curves, then before you're running this simplify by straight line tool, what you want to run is the merge collinear, the merge collinear boundaries tool. So this tool will let you merge collinear lines together and get rid of those parcel points, and what you'll see left over is the vertices, and from there you can continue exactly with the same demo we just saw now. I hope you find this helpful. Have a good day.